Hello everyone, so I'm here for a short lesson on trapezoids and trapezoidal sums. So basically what trapezoids are is they are another way that you can estimate the area. So one thing they kind of let us do is they kind of let us take an average of the left and the right Riemann sums. And of course we're talking about an area under a curve. So basically let's go back to a problem that you might have seen back in geometry. Like what if I have to find the area of this shape? So if I find the area of this trapezoid, this is a trapezoid that I'm going to set on its side, and the side lengths will be 8 and 6, has a base of 4. Now what some of you guys might do is you might draw a little horizontal line across and say, okay, well, that's 2 above it, that's 6 below it, so then it's like 4 by 6, and then on top you have a half times 2 times 4, so that turns out to be 28. Great. But there's another way that you can do this, and this is the formula I want you guys to know. The area of a trapezoid, if it's turned on its side like this, is equal to 1/2 base times height 1 plus height 2. Basically, you're averaging the two heights. So this is the formula we're going to use. This is the area of a trapezoid. And in this case, the trapezoid, we have a base there of 4, so my distance on the x-axis, of 8 plus 6, which still gives you 28. Great. So that's how you find the area of a trapezoid. Now, when we're approximating an area with a trapezoid, it basically looks like this. Like, say you have a curve, I don't know, that looks like that or whatever. So let's say you have two trapezoids. Let's say you're splitting this up, like 0, 3, 6, doesn't really matter. What you're doing is you're using the height on both sides and then using that to draw a trapezoid. So if you're going from 0 to 3, you use the height at 0 up to that point, you use the height at 3 up to that point, and then you use a trapezoid like that. So that's what you're doing. You're using the height on both sides and kind of essentially getting the average of those. So from 3 to 6, you find the height at 6, and then you draw the line. So as you can see, this actually does a pretty nice job of like estimating curvature and showing curvature when you're doing things like that. So it turns out to be very, very good, and this is the key formula we're going to use. So let's look at some example problems here. So suppose I give you a table with x and f, and x goes 0, 1, 5, 7, 8, and f goes 8, 6, 3, 5, negative 1. And I'm going to ask you to estimate the integral 0 to 8 using a integral 0 to 8 of f using a trapezoidal sum. Now, just like we could estimate this with a Riemann sum from the table, we can do it with a trapezoidal sum as well. And just like before, I want to write out what the intervals are. So the intervals here, of course, are just the same, the distance between the x's like that. So intervals are 0 to 1, 1 to 5, 5 to 7, 7 to 8. Within each interval, I'm going to use both heights. I'm going to use the height at 0 and the height at 1, the height at 1 and the height at 5. Now, I also think it might be good to write down the bases. Right here, my base is 1, here my base is 4, here my base is 2, here my base is 1. So as I go ahead and work this out then, what I'm going to get is I'm going to have 1/2 times a base of 1, and then I'm doing the two heights together. So it's like f of 0 plus f of 1. So I take those values, so that's 8 plus 6. And just like with the Riemann sums, I'm going to add all these together and just try and sum them all up, and that'll give me my answer. So the next one again is 1/2 base, and then I do height 1 plus height 2. So I go from 1 to 5, I have a base there of 4. My heights at 1 and 5 are the values of the function, 6 and 3. And then 5 to 7, I have a base of 2. My heights 5 and 7 are 3 and 5. And then 7 to 8, of course, I have a base of 1. Heights there of 5 and negative 1. Don't do anything different with negative. It still works out. Okay, so now let me teach you just some tricks here. You can leave this alone, by the way, but basically this is 1/2 times 14, so that's going to be 7. The 1/2 and the 4, those like half of 4 is 2, so that's like 2 times 9, so that's plus 18. This is very poorly written 2. 1/2 times 2, those just cancel as 1, so that's just plus an 8. And then 1/2 times 4 is just 2. So 7 plus 18 plus 8 plus 2, oh gosh, I don't know, that's 35. Okay. So same thing, you're just trying to estimate an area, but you're using these trapezoidal sums. Let's do another example with an equation. So let's say I ask you to estimate integral 1 to 7 of square root x plus 2 dx. Excuse me. Using two trapezoids, I don't have COVID, don't worry. Using two trapezoids of equal width. Okay, so let's work with this. We're trying to go from 1 to 7. So in the middle of that, 2 trapezoids, that has a width of 6. So the middle of that is 6. So we're going to go from 1 to 4. Sorry, the middle of that is 4. So we're going 1 to 4 and 4 to 7. So each of those have a base of 3. So now I'm working this out. I have 1/2 times the base of 3, and then I do f of 1 plus f of 4. I use the height of the two endpoints added. And that's my function. That function is root x plus 2. So now I plug in 1. Well, root 1 plus 2 is square root of 3. When I plug in 4, 4 plus 2 square root of 6. 3 to 7, again, I have a base of 3. I plug in the 4, I have square root 6. When I plug in the 7, I get square root 9. That's kind of cute. So anyway, we're going to get 3/2 times root 3 plus root 6 plus 3/2 times root 6 plus 3. And I don't see anything else you do. You just leave it like that. Okay, so that's how trapezoids work. It's all about that formula 1/2 base, height 1 plus height 2. Use height at both endpoints. But the strategies are pretty similar in terms of intervals and whatever with Riemann sums. Okay, speaking of Riemann sums, I had one more thing I wanted to share with you. This is off topic from this, but that's okay. Over versus under estimates using a Riemann sum. I did not spell that correctly. Over versus under estimates of a Riemann sum. So we're basically going to try and answer this question. If you have a function f of x, if that f of x is increasing, will a Riemann sum of integral a to b of f of x be an under or over estimate? And you'll see this kind of question occasionally on AP tests. It'll be like, find a left Riemann sum. Is it an under or over estimate? And the key thing on here, well, I guess two key things. One key thing is that the function's increasing. But the main thing I wanted to tell you to do is just draw a picture. Just draw a picture of some increasing function. If you have an increasing function, let's just sketch this out. Okay. So now, if I were to take this increasing function and split it into just a couple intervals here, and if I did a left Riemann sum, so that's saying like I go up to the left endpoint and I go over. I go up to the left endpoint and I go over. Now, hopefully you guys agree this is missing some area, right? I'm not counting this area in here. So that would tell you that this left sum of an increasing function is an underestimate because it missed some area. It didn't find the real area. And the opposite's going to be true on a right sum. So if I'm going up, if I, again, split this into intervals, and I use the height of the right endpoint, so use the height of the right endpoint, go over, use the height of the right endpoint, go over, we can see the opposite, right? It overcounts this area. So a right sum of an increasing function is an overestimate. It counts too much area. Now, this is not something I would ever memorize or spend time studying. I just draw a picture. And you'll see, of course, that the opposite is true if f is decreasing. Right? If you have a decreasing function, if you are a right Riemann sum and a right Riemann sum, it's an underestimate, right? A right sum is an underestimate. If you have a decreasing function and a left Riemann sum, it counts too much area. It goes over and counts the extra area. Okay, so that's how you do these problems. If it asks if a Riemann sum is under or overestimate, your function will always be either decreasing or increasing, and just draw a picture to help remind you. Okay, so that's that. Bring me some questions in class. I'll see you guys soon.